Hello everyone, once again. I am here to present my erosion screencast. And so for this activity, we were to follow the engineering design process that was given to us within the module. And before I proceeded with the activity, I checked out the runoff simulator program online, and you can see here I have a couple screenshots of a couple different scenarios that I set up. Some different development levels and some different soil characteristics, and I was able to see the amount of infiltration and runoff regarding each scenario. And so to move into the experiment then with the design process, the first step is to identify what is the problem. And we had to design an experiment to show us how soil and land cover impact infiltration and runoff. And so the next step, imagine my son and I went on a little scavenger hunt around the house, see if we could come up with some supplies and determine how we could proceed with this experiment. And then the planning stage, we took our materials, we manipulated them and modified them to suit our needs. And over here on the right, you can see our 3 different test samples. We have plain dirt, we have dirt with mulch, and we have dirt with grass. And then we conducted our experiment. We did the testing and evaluating, and the results were what we had anticipated. The plain dirt, the water flowed through quite quickly, and the dirt or the water was quite dirty. The second sample with the mulch, the water was not as dirty, and with the grass test sample, the water was cleaner, and it seemed to take a lot more water to fill the cup. And lastly, over here, I am squeezing out the water out of the grass. You can see here some of the water coming out, and the grass roots and so forth were able to retain much of that water and hold back the soil. So lastly, to improve or make it better, I think you could do this experiment possibly testing some different soil types to see the infiltration and runoff with different soil types and the effects of that. You can incorporate more math possibly by having students measure out exact amounts of water and possibly measure the flow rate out of the bottles. And to conduct further investigations at the conclusion of this activity, I think you could extend the learning by taking the students possibly into another problem-solving exploration process in which they can maybe explore some solutions to reducing the footprint of residential and commercial development. For example, vertical parking garage rather than a parking lot. And then you could introduce some civil and architectural engineering concepts as well. Here are the next generation science standards that I had located that I thought pertained nicely to this activity. And then the connections among STEM practices highlighted are the ones that I felt were appropriate to this activity. Thank you very much, and I will take any questions or comments on our discussion board.